Conditional probability is one of those topics that people often find really tricky. The way to make it simple is sort of just to act out what it really means when someone puts a condition on something. It sort of limits the choices, doesn't it? For example, if you say, "Mum, can I watch TV?" and your mum says, "On one condition, you have to tidy your room first." Then you say, "Oh sure, I've already tidied my room so I can watch TV." Or if you haven't tidied your room, you know you've got no chance at all of watching TV until that thing's done. So the condition is the thing that needs to be met to be able to do something else. So we've got a formula for conditional probability, and some people love using formulas. It's actually on your formula sheet too, although it doesn't say this is the formula for conditional probability. You have to recognise it. Now the formula makes tons of sense. Feel free to use it. I'm going to show you how to use it, but I'm also going to show you a second method. You can use the formula, or you can use the method that I like to call putting a spotlight on the event that is the condition. Now, new terminology for us, this line, vertical line here, means given. So what we're saying here, the probability of A happening, given that B has to have happened. In other words, the condition is B. It's like you saying, what's the chances of A? And you say, well, I'm only looking at it if B has happened. So the chances of A happening, given that B must have happened, before we look at our formula, let's just think how it would work in action. We've already looked at how many students in our class do art or music, or both or neither. So let's use these numbers again. And I've written up the same Venn diagram, but also using probabilities, because you'll notice there's two versions of the formula here. One uses the number of items that are, or members that are in the intersection of A and B, over the number of items that are in B, and the other one uses probabilities over probabilities. Now you can do it either way. Which one should you choose? Well, if you know the probabilities, you'll use this version, and if you know the number of items, then you'll use this version. So if we're saying, what's the probability of, say, art given music? What we're saying is, given that I know a student in here does music, in other words, I'm going to ignore everyone that doesn't do music, what's the chance of getting an art student out of those? Well, how many students do music? 2. What's the chance of choosing a student at random out of those 2 and getting an art student? It's going to be 1 out of 2. Now, can you see there we've basically used the spotlight method right from the start here. We've said, okay, the chance of art, given that they have to do music, means I can just look at the music bubble and put a spotlight on that and ignore everything else. And then it's a really simple question. What's the chance of getting an artist out of those 2? 1 out of 2. Now, can you see that it's the number of students that are in the intersection, 1, over the number of music students altogether, 2. That's actually what we did there when we put that spotlight on. Similarly, we could say that we've got 1/11 out of 1/11 plus 1/11, which is 2/11. Now, the working for that would be a lot more complicated. So, answering this question here, using my formula, I think these numbers would be easiest to use. I've basically got 1 out of 1 plus 1, or 2. And using this method, if I knew the probabilities, I would write equals 1/11 out of 1/11 plus 1/11. I can do 2/11 in my head. Now, straight away, a bit of a problem and a possible cause of error. Doing fractions over fractions always looks a bit awkward, doesn't it? I would prefer to say I've got 1/11 divided by 2/11. At that point, you could put it in your calculator, or you could say we can times and flip. The 11s cancel, and obviously either way we do this, we still get a half. But can you see how applying the formula, much as it's easy to do, might not be quite as quick as actually just using this spotlight method of saying, okay, well, how many people do this second thing? All right, so here we've just learned how to figure out the probability of choosing an art student given the condition, which is they must do music. The second thing is the condition, okay? So perhaps you might want to write on your notes here that B is the condition. So it's the certainty. So you put your spotlight on B, and then you say, what's the chance of the other thing? Where B is the second thing here and A is the first thing, obviously. All right, what's the chance that a student chosen at random in our class does music, given that I know they do art? All right, now our spotlight is on just the artists. How many of them are there? There's 5. What's the chance that one of them does music if we choose one at random? Well, how many do music? 1 out of 5. I can actually use that spotlight method and just come up with the answer straight off the top of my head. If I was using this method, again, I would have the number that do both 1/11ths divided by 5/11ths, and that's still going to give me 1/5.